Where the rest of the students? My laptop screen is visible from your side.
Yes, sir.
PowerPoint presentation is visible from your side. Please answer
Yes, sir.
anyone. Yes or no?
Yes, sir.
Okay. So only 11 students still. Okay. I think you got the message from Abhishek, na? Yes or no? Abhishek is there. Abhishek is not there. You see here, Abhishek join. Abhishek, please tell me, have you got the message? The I can take the class from 11:30 instead of 11 o'clock. Yes or no?
No, sir, we didn't get message of like delay of the class.
Oh, you got that message, na? But the message actually I can send in late, of course. But you got that message. Okay,
No,
so
sir, we didn't got that message.
we did not get that message. Okay. Actually, I did not contact your CR because he's not received the phone call because maybe in class or some problem. But I can send a message uh, to Abhishek to inform him, all of you, the class will be delayed half an hour. Okay, baby. Okay, can I start 19 only 20? I think problem in bandwidth or something here. Okay, can I start my presentation, or maybe that means there is some miscommunication. The class actually shifted from 11 to 11:30 for this today. Okay, I can start my class. The rest of the please inform the other students by your message, by your through your group. The class is already started, if possible. I think some problem is there in the network. Okay. Okay. Hope the PowerPoint presentation, the slide is displayed in your screen. Uh, is it okay? You can see in the PowerPoint presentation the slide number 14. Yes or no? Anyone, please?
Yes, sir, visible.
Yes, sir, it's visible.
Yes, sir.
Okay. Okay. The key, that is the super key, primary key, foreign key, candidate key. I already defined in case of entity relationship model. That is the what is the super key, what is the primary key or candidate key for the entity, or and Hello, am I audible, please? Actu-
Yes, sir.
But how long actually I disconnect? I just seen that I already disconnected from you.
Sir, when you shared the screen, at that moment only you were disconnected.
Okay, that means whatever actually I taught, that is not listened by any one of you.
No, sir.
Sorry, I think due to network problem. Just a minute. Now, PowerPoint presentation is visible from your side.
Yes, sir.
Okay, please respond. Otherwise, it will be difficult to find means sometimes due to network problem or I may be disconnected from the presentation. Okay, here we want to talk about the relational model. The relational model means basically there are collection of that can be described by a collection of relations, or this is synonymously we can talk about the we can consider the relation is the equivalent to a one of the table. So relation, what is the relational schema? What is the relation? I already considered that discussion in my last class. Okay, relation. This one the case. A1 to up to an are the set of attributes, and this set of okay, it's better actually. Just 1 minute. Here you can see the A1 up to an are the set of attributes. Am I audible, please? Set of attributes, and here the relational schema R is defined on the set of attribute A1, A2 up to an. Okay, that is relational schema is basically it is a structure. What are the attribute? What is the domain of each of the attribute that can define in the relational schema, and the relation is defined on the relational schema. So, so if suppose the K is the subset of relational schema R, that means K is the basically subset of the set of attribute which define the relational schema R. What are the attribute actually define the relational schema? A1, A2 up to An are the set of attributes. K is the that means subset of the attributes. Is it clear? K is basically a K is basically a subset of attribute A1, A2 up to An. Okay. So now we can say the K is a super key of the relational schema R, capital R, if the values of the K means number of attributes, that is a subset of the attributes of the relational schema R. The values of K, that is this set of attributes, subset of the attributes, are sufficient to uniquely identify each of the tuples in the relation small r, which is defined on the relation schema capital R. Okay, that is super key is basically a one or more attribute which uniquely identify each of the tuples or each of the rows in a table from the relation R, small r, or from the table smaller, and which table or relations define on the relational schema capital R. For example, say customer relation, the customer name and customer street is the super key. Customer name is the super key. Similarly, customer name and combination of customer customer city, this combination customer name and customer city, it is also a super key, one of the super key. Similarly, customer name, customer city, and customer street, combination of these three attributes is also a super key. You got my point, na? Because all of this set of the attributes, maybe this set, maybe this set, or maybe this set, can uniquely identify each of the tuples from the relation customer. Okay, so these are the super key, and here we assume in the customer relation no two customer name can be possible with the same name. That is, customer names are distinct. We assume here. What we assume? Customer names are distinct. For that, each of the super key can uniquely identify the tuples from the customer relation. But if we consider the customer, I mean uh, customer name is not distinct, that is the same customer name is possible or exist, then we can need to be add one of the more attribute customer ID. So at the time, in place of customer name, we can write the customer ID. So this is the super key. Now, am I audible, please?
Yes, sir.
Yes, sir.
Okay. Now, this super definition of super key, candidate key, primary key, foreign key, that's similar to the whatever we discussed when you talk about the super key, candidate key, primary key for the entities, different entities, and as well as the different relationships. Okay. So now question is actually what is the candidate key? Please tell me anyone, what is the candidate key? What is the candidate key, Projata? Candidate key is the minimum number of attribute which can uniquely identify the each of the tuple from the relation. That is the minimal super key. Is it the candidate key is the minimal super key? Candidate key is the minimal super key. That is the, we can say the k is a candidate key if k is minimal. Okay, that is the k is the super key here. That is, it is a candidate key is a minimal super key. Okay, it is a minimal super key. So in this example, among this super key, which one is the candidate key? Here, minimum number of attributes are present. Where? Which one is the super key? Sorry, which one is the candidate key, please? This one, because this is the minimum number of attributes or minimal super key. So customer name is the candidate key of the customer relation. And of course, here we assume the names are distinct. That is the, there is a no two customer have the same name, and there may be possible more than one candidate keys are there, may exist more than one customer key, candidate keys. So during that time, one of the candidate key can pick up, that can serve as a primary key. That is, if only one candidate key is there, that means that candidate key serve as a primary key. And there may be possible more than one candidate key exist in a for a particular relation. So during that time, any one of the candidate key can consider as a primary key. Okay, that is candidate key and primary key. Is there any question, please? Any question up to that? No. Now next is what is the foreign key? I already told the foreign key of a relation R is the set of one or more attribute that uniquely identify the tuple of the another relation. So foreign key is basically a one of the primary key of the another relation. Suppose the two relations say R1 and R2. In this two relation, here suppose the attribute A1 and A2, say A3 is there, and here suppose the A3, A4, A5, say A6. That is relation schema R2 have the four attributes A3, A4, A5, A6, and relation schema R1 three attributes A1, A2, and A3. Suppose A3 is the primary key. A3 is the primary key. This is the primary key. That is primary key means that uniquely identify each of the tuples in the relation. So A3 is the primary key of the relation R2. Now you can see A3 is present in relation R1 also. A3 is present here also in another relation. So at that time we say this is foreign key. Okay, that is foreign key is defined. Foreign key is defined in a second relational schema. That is in this case R1. Foreign key is defined where in R1, but it refers to the primary key of the another relation. Okay, so it's better actually I give the name for the sake of clarity. This is a R2 and this is a R1. Okay, so A3 is a primary key of the relational schema R1, whereas A3 attribute is a foreign key of relation and schema R2. Okay, is it clear? Basically the foreign key refers to the another table or another relation where that attribute or set of attribute act as a primary key. Is it clear? What is foreign key is clear?
Yes, sir.
Now, what is the strong entity set? How the primary key is computed? Weak entity set primary key or defined relationship primary key? I already discussed in my earlier class, but here actually just quick revise. Here the strong entity set. In case of strong entity set, the primary key of the entity set becomes the primary key of the corresponding relation when we convert this one in a relation or table. And in case of weak entity set, which one is the primary key? When we convert this one in a relation or table, the primary key is the combination of or union of the primary key of the strong entity set on which the weak entity set depends plus discriminator of the weak entity set. That is union of the primary key of the strong entity set and the discriminator of the weak entity set. This combination is the act as a primary key of the weak entity set when we convert this weak entity set into a relation or table. That is the relational table we already told you that can be used synonymously. This one I already discussed, na? Is it? Can you remember this
Yes,
one?
sir.
Just few days
Yes,
back
sir.
I discussed it. How we can convert the strong entity set into a table and what is the primary key of that table, corresponding table. Similarly, in case of relationship, when this relationship is converted into a relation or table, then how the primary key that depends on the basically how form the super key that depends on the cardinality. That is, it is a many to one, or it is a one to one, or it is a many to many. If it is a many to many, then union of the primary key of the both the relation, that is both the entities sets, are the primary key of this uh, relationship set or relation which convert the relationship set. So you can check in my previous slide the last chapter actually ER data model. Okay. Is it okay na? Because there is a lot of discussion I have done in the ER diagram. Now schema diagram, this is a relational schema diagram basically. This is a relational schema diagram for the banking enterprise. This is not the ER diagram. That ER diagram actually converted into a relational schema diagram. You can see here. You can see here the customer in customer entity set. If you see this one, you can see here the customer. In customer, what is there? Customer name. It is a ER diagram, na? Customer name, customer city, and customer street. Account entity set. What is there? Account number and balance. Okay, account number and balance. Similarly, in branch, what is there? Branch name, branch city, asset. But for relationship depositor, there is a one of the relation depositor is there. But for account branch, I already discussed in my previous classes. The sometimes the conversion of relationship into a table is redundant. It is better at that time the attribute, one of the attribute, descriptive attribute, if any, that can be added to the another any one of the connective entity set. That is the primary key of the other can consider as a, for example, suppose in the relational schema we have not considered this one as a one of the table or relation. Okay, instead of that the this primary key, that is the branch name is the primary key, this branch name can consider one of the attribute of the account table or account relation. Do you understand? In case of entity set, account entity set consists two attributes. What are the attribute? Account number and balance. Okay, but when we consider this account as a one of the relation, during that time we have not create any table or any relation for account branch. Instead of that, in account table or account relation, we add one of the attribute. Which attribute? Which is a primary key of the connected entity set. This relationship connect which entity set? Branch. What is the primary key? Branch name. So you can remember this. That is in that case the account relation consists of account number, balance, and branch name. Now you can see here. You can see here the account. This one. Account relation in the relational schema. Account number is there. Account number is the primary key. Branch name is there, and balance is there. And in the branch relation, branch name, branch city, and asset is there. What about the attribute present in the entity set also? Which one is the primary key? Branch name is the primary key. Now you can see here. Can you tell me from my previous just the discussion from the different keys, primary key, foreign key, candidate key. So among these two relation, branch and account, which one is the primary key and which one is the foreign key? Please tell me anyone from you. Anyone from you, please.
Sir, account number is primary key and branch name is foreign key.
Good. Account number is the primary key of the account relation or account table. But whereas the branch name act as a foreign key here, which refers to this branch name actually connect to the branch relation or branch table, where branch name is the primary key. Here this is the primary key. Account number is the primary key of the account. So branch name attribute is the primary key of the branch relation, and branch name is the foreign key of the account relation. That is, in account relation, this foreign key branch name basically refers or connect to the branch relation. Okay. So suppose you try to understand. Suppose what is the use of that? Suppose I want to take the information, the account number, balance, and branch name and city of the branch. But you can see if we consult in that time the account relation, only this relation, the branch city is not present in this relation, is it? No, only the account number, branch name, and balance is there. Branch city is not there. So at that time, which table or which relation need to be consult? Need to be consult this branch relation. So how actually relate these two? Means I want the branch city for the account number, corresponding account number. So during that time, this branch name and this branch name need to be matched equal. At that time, the branch city will be displayed. Do you understand? Similarly, uh, in case of loan relation, the when we talk about the loan entity, at that time loan number is there, loan number serve as a primary key, and branch name is there, sorry, amount is there. But here the loan branch relationship we have not considered as a relation. Instead of that, add a one of the attribute branch name here. Okay, so these are the different relations. So finally, in our simplified banking system, what are the relations we have considered for the example purpose, example query purpose, in future discussion? The six relations or six tables. What are the name of that? The branch. The name of that, please. Branch. Please tell me. Branch, account, depositor, customer, borrower, and loan. So the relations in the banking example comes from the previous diagram. That is the branch. The branch relation defined on the, what are the attribute? Branch name, branch city, and asset. Similarly, account, account number, branch name, and balance. Okay. Up to that, any question? If any question, please clarify. Any question? Yes or no? Similarly, in case of loan table, this branch name act as a foreign key. Okay, and here also the this one act as a foreign key, whereas this one as a primary key of the branch relation. The idea of foreign key and primary key is clear. Yes or no? Hello. Am I audible, please?
Yes, sir.
Please tell me, otherwise it's difficult because the due to network issue or if you have a doubt, then you can clear it. Otherwise, I can complete the syllabus. That can take a very less time, and that can be better for me. But this class basically for your understanding purpose. So, to please response, and as well as the if you have any query, so you can ask the question. I try to clear it. Just a minute. lot of problems in the network. Okay, just a minute. So here the idea of the defined keys are actually clear. So these are the actually set of relation or set of tables and corresponding attributes, because this relation in our query example, when you talk about the relational algebra, we can consider that sorry, we can consider this set of relations in the banking example. Now I already told the language, query language means actually in which user request information from the database. That is, if we want to retrieve some information, or we want to see some information, how actually we can request to the database? Through the query language. Okay, there are two type of query language: procedural and non-procedural. In my introductory class, I already told you what is the procedural query language. The procedural data manipulation or query language requires user to specify what data is needed and as well as the how to get it. Whereas in case of non-procedural, user can only specify the what data is needed without specifying how to get it. So in case of non-procedural query language, because in that case, non-procedural query language, there is no need to user no need to require to specify how to get the data. So for that, the inside the database, there is a complex code is generated, and that takes a extra time. To reduce that, there is a defined several query optimization techniques are there. So that query optimization techniques for SQL is also included in our syllabus. So now procedural query language, that is relational algebra, is the procedural query language, and whereas the tuple relational calculus and domain relational calculus, both the relational calculus are non-procedural query language. So and these are actually called a pure query language. Why? Because this actually forms the basis of the query language. Okay, any commercial query language is developed on the basis of this pure query language. Okay, these are not the commercial query language. That is pure query language form the underline of the basis of the query language that people use. That is the basis of the underlying commercial query language. Now I want to talk about the relational algebra. I already told the relational algebra is the procedural query language. That means user need to specify what data is needed and how to get it. In relational algebra, there are some of the basic or fundamental operations. This relational algebra, there are number of operations are there. Okay, some of the operations are actually fundamentals, and some of the additional operations are there. Additional operation means, I think it is clear, that operation can be derived from the basic or fundamental operation of the relational algebra. Okay, what are the fundamental or basic operator? That is select, project, union, set difference, Cartesian product, and rename. That is these six operators, or that operator of course perform the operation. That is these six operation of the basic operation or basic operator in relational algebra. There are several other additional operator are there that perform the other operation, additional operation, but that additional operator we can derive from this basic operator, using this basic operator. Okay, do you got my point now?
Yes, sir.
Because for example, in digital logic, suppose digital logic, which one is the basic gates? NAND gate and NOR gate, normally called, na? So by using the NAND gate and NOR gate, you can use or you can design the any gate or any circuit. Or if you go to the more specifically, then the fundamental blocks are there: AND gate, OR gate, and NOT gate. So similarly here, the select, project, union, set difference, Cartesian product, and rename, these 6 operators are the fundamental operators. Additional operators can derived or developed by using these fundamental operators. And these fundamental operators, select, project, union, that takes one or more relation as the input. That is the parameter of this operator are one or more relations. Okay. And what is the outcomes? Outcomes is the relation. That is the result is also a relation. That is this. Is it clear? The select, project, and these 6 operator, each of the operator perform the operation on the one or more relation. Maybe unary operator, maybe binary, or maybe more than more than 2 relation also. And output after perform the operation, it produce some output or result. That result is also treated as a one of the relation. Is it clear? This is one of the important point. It takes a one or more relation as a input and produce the result, which is also a relation. Now, first the select operator. In case of select operator, what is the symbol of the select operator? Sigma. This sigma is the symbol or notation used to signify the select operation. That is, select operator is the sigma, and this P is the selection predicate. That is the condition. This I already told that each of the operator or operations in relational algebra perform on one or more relation. That is, it can take one or more relation as an input. So here the basic form is the sigma P R is the relation. Okay, this is the basic form. So what is this? This is the set of tuples. This is a set of tuples. Tuples is clear. Each of the row in the table or each of the record in the file, that is the tuple. That is the rows in a relation is called a tuple. That is this. This provides the result. What is the result? Result contain the set of tuples. Which tuples? The tuples belongs to the relation R. That is this operator perform on which relation? Smaller. D belongs to R and predicate PT is satisfied. That is, this condition is true. Is it clear? You got my point? Say relation R.
Yes, sir.
Relation R consists number of rows or number of tuples. Each of the line you can think like a tuple or records or maybe the rows in a table. This one outcomes some of the tuples from that. Which tuples? Those tuples satisfy this condition or this predicate. Okay. Now this predicate, the predicate P is a formula in the propositional calculus and consisting the different term. The terms are connected by AND condition, OR condition, and NOT condition. Okay, these are the connectivity. The two terms are actually connected by AND connectivity, OR connectivity, or NOT connectivity. And what is the term? Term is the attribute, operation, attribute. Okay, where OP is the equal, not equals, greater than, less than. Okay, these are the basic formula of the propositional calculus. This slide, you have any doubt or any question, then we can go for example. I can again repeat. This is the first fundamental operation in relational algebra, which is the select. How we represent, what is the notation or symbol used? The symbol sigma is used to represent that. What is the basic form? Sigma p. P is the predicate or condition, and this select operation perform on a particular relation R. Maybe the relation R is the customer, or maybe the relation R is the account, maybe the relation R is the loan or depositor, so on. So this gives us a what actually outcomes of that operation? Outcomes of the set of tuples T. Say R relation consists of number of tuples. This is the tuple 1, say tuple 1, tuple 2, tuple 3, and so on. From that, which tuple actually selected by this select operation? Those tuples satisfy the this condition, that is the this predicate. That is, of course, the tuple is selected that is belongs to the relation R, and as well as satisfy the condition. That tuple comes as a output. Okay. So outcomes is, or result is also a another relation. That is, the result is also a here set of tuples comes from the relation R. And this predicate P formula, selection predicate P is formula in a propositional calculus that can consist a number of terms. The how actually terms are actually connected by the connectivity and or not. What is the term? Term is the attribute, operator, attribute, or maybe that is the attribute, operator, attribute. Okay, or attribute, operator, constant. Okay, is it clear? And what is the OP or operation? Operation is the here greater than, equals, not equals, less than equals, so on. Okay. So suppose, for example, balance is the one of the attribute, na? Balance is the attribute of the which relation? Account relation. Is it? Is it or not? Yes or no? Balance is
Yes,
one
sir.
of the attribute of the account relation. So we can write here, say balance greater than equals, say 10,000. So this is a one of the what? This is one of the term. Is it clear? That is balance here attribute, and this is a constant. That is this satisfy this one. Attribute, operation, constant. Okay. I think it's better actually we can discuss now next with example. Now suppose the relation R. Okay. How many attributes are there in this relation, example relation? Please tell me. How many attributes? 4 attributes. A, B, C, and D. Is it? Yes or no? And how many tuples are there here? Anyone, please? How many tuples?
4.
How many tuples? 4 tuples are there. That is, this is the tuple T1, second tuple, third tuple, and this is fourth tuple. Okay. Now, if we write, say, perform the operation, say this one. Sigma means select. We can read as a select. This is the predicate, and this select operation perform on the relation R. What is the R? R is this one. So in that case, what is the outcomes? Outcomes are the set of tuples from R. Which tuples? Those tuples satisfy this condition is true. So what is the condition here? A equals B and D greater than 5. So where A equals B? In which case A equals B? This is the A equals B. This is A equals B. This is A equals B. Yes or no? Do you agree? These 3 tuples T1, T3 and T4 there, A equals B is there. Okay, and where D greater than 5, you can see here D greater than 5, here D greater than 5, here D greater than 5. So what is the connectivity is there? What is the connectivity? What is the connectivity? And connectivity.
And
So when
connectivity.
both the condition is satisfied, when both the condition is satisfied,
In case of T1 and T4.
that is, in that case condition, both the condition is satisfied, true, predicate is true finally, and here predicate is true. So what is the output of this operation? That is select
T1.
A equals B and D greater than 5 on R relation R. This is the output. That is T1 tuple and T2 tuple. That is this one and this one. It does not consider the this one and this one. Why? Because here beta equals beta, but here D greater than, but not satisfy both the condition, because here connectivity is AND. Is it clear? Yes or
sir.
no? If we write simply just say D greater than 5 on the relation R. So what is the outcomes of that? What is the outcomes? Say A,
T1.
B, C, D. What is the outcomes? Alpha,
T1, T2,
alpha,
T4.
1, 7. That is the alpha, beta, 5, 7. And T4 is the, that is the beta, 23, 10. Good. Okay. This is the outcomes of this. Okay. I think there is no confusion. So now tell me, find the account information of the NIT Durgapur branch. Account information of the NIT Durgapur branch. So now we come in a real example. Find the account information of NIT Durgapur branch. To get the NIT Durgapur account information, which relation need to be consulted? Which relation need to be consulted? Right. Which relation need to be consulted from among these 6 relation? Which one actually consists the account related information? Is it na? Yes or no?
Yes, sir.
We want the account information for the NIT Durgapur branch. So what we write? Select branch name equals, what is the condition? Branch name equals NIT Durgapur. And inside the bracket, what is the name of the relation? Name of the relation is the account.
Account.
So here we write the select branch name equals, this is the predicate, branch name equals NITD. Inside the bracket, relation name, what is the constant relation name? Account. Because the account information stored in the relation account. Okay. And here condition is there, we don't ask for the all the account information, only for the account information of the NIT Durgapur branch. So here we that one write in as a predicate. Okay. Is there any question? So next operation is the project. Project is notation is the pi. That is the symbol used. Just I change the color. Symbol used for project operation is the pi. Okay. What is the basic format or how we define pi? The set of attributes inside the bracket relation. I already told the each of the operator or operation perform on the one or more relation. So here relation is the input, and this set of attributes is the outcomes. Okay. So what is the output of that? Outputs are, in that case, the attribute value A1, A2 up to AK. Okay, from the relation R. Suppose in relation R, say relation R is a is arity n. Arity n means how many columns are there in relation R? N number of columns are there. Okay, So among the n number of columns, this project operation actually consider only the k number of this specified k number of attributes from the n number of attributes in the relation R. I already told na relation R actually consists how many attributes? A1, A2, A3 up to AN. So among these k number of attributes values are result or tuples are result in case of project. So in previous case select the whole tuple, that is the all the attribute values belongs in the particular tuple in the relation R. But here actually may consider the some subset of the attribute values in each tuples. Which subset of the attribute values consider this project operation? Which attributes name are specified here? Which attribute names are specified here? Okay. And here the result is also a relation. And how many columns or how many attributes are there? K number of columns. What are the columns? These are the columns. A1, A2 up to AK. That is, in relation R, if there are n number of columns are there, it can result only up to k number of columns, and remaining columns are erased means not discard from the relation R and present as a output. And also another important point, duplicate rows are removed from the result because the relation are set. So in all cases, if there is any duplicate row, that can be removed because the set relation is the set. The outcomes is the relation. Any operation, the outcomes is the or result is the relation. So if any duplicate rows are present, then that can be eliminated by default in that case. But that is not possible in case of SQL. When we talk about the SQL chapter, at that time we can discuss this one in details. Now, for example, suppose the relation R consists the please tell me.
Sir, in previous slide, sir, last line, sir,
Just a minute.
duplicate rows are removed from result. Sir, so
Yeah.
after creating k columns, if some two rows are duplicate of each other, then we remove them.
And that will be you can remember that will be more clear when we take the next other example, because here only one relation is the input, but in relational algebra this is basically one of the expression, relational algebra expression. This one is the one of the expression. Similarly this is also one of the expression like that. But the combination of expression is also a relational algebra expression. That is, if suppose E1 is the one of the expression and E2 is the another expression, so E1 and E2 combination by some other operation, that also a one of the expression. So in that case, maybe after result, maybe chances are there that can create the duplicate values or duplicate tuples. So during that time, that duplicate tuples automatically removed from that. Here actually not possible, because in this single example it is not there, because R is a relation. So by default in R there is a no duplicate is there, is it na? So
Yes,
result of the subset of the attribute values, there is a no duplicate is there. But when it can operate means in complex case, we can discuss this one in later. During that time, maybe chance the duplicate actually comes, because when you consult the two relation, say suppose branch and account. The branch relation, already branch name is there, primary key, and branch name is present in the account relation also. So when we combine these two relation into a single relation, for that Cartesian product operation is there, we can come later. When we combine that, at that time the duplicate values or duplicate rows actually comes. So the result automatically or subset automatically remove the duplicate. Okay, we can discuss when that cases actually comes. Okay. Now suppose the relation R is consists of three attributes A, B, C. Okay. So if we write say pi, that is the project operation, attributes are A and C on the relation R. That is, relation R actually consists, these are the value. This is the tuple 1, this is tuple 2, this is tuple 3, tuple 4. So for that, what is the result? After execution of this project operation, what is the result? Result actually consider only the values from attribute A and attribute, oh sorry, extremely sorry, just a minute. And from attribute C. That is, the result is this one. That is, you can see this one is present. This one is present. This one is present. Okay, you can see what your question, it is comes here also. This one and this one. Okay. Now you can see, is it, do you agree with this result? Do you agree, yes or no?
No, sir.
Yes, no? Yes or no?
No, sir. Duplicate is there, sir.
That is the point actually. The result actually of that is content of the column A and content of the column C actually is pick up. So because the outcomes is the relation, so it is a relation, but for that this duplicate is not present. So final result is this one. So duplicate actually removed finally, and this is the final outcomes. Okay. The by definition content of A and C actually comes here. Okay. And from that eliminate finally at the intermediate stage, eliminate the duplicate tuples and comes this is the final relation. Suppose if we write say pi say A on the relation R. So what is the outcomes of that? Please tell me anyone. What is the outcomes of that? Just simply write this project attribute A on the relation R. Yes. Please pardon me. What is the outcomes? Outcomes is the relation which consists how many attributes? Please tell me how many attributes?
Only one, sir.
Sir, 1.
One attribute. That is the attribute A. Okay. That is the attribute A. And what are the content? Content is the
Alpha, beta.
and beta. Because consider this row, this column, and after elimination of the duplicate, that is the alpha, its intermediate stage is the alpha, beta, beta. So after removing the duplicate, this is the final result. Okay, this is the project. What is the role of the project operation is clear. Okay. Now, suppose the question is to eliminate the branch name attribute of account relation. How we do this? Please tell me, anyone from you. Just I want to take 10 minutes more. Okay, so I can consider this one as a 2 periods. What is the question? Question is eliminate branch name from the account relation. It's for your, okay, just a minute. For your simplicity purpose, it need to be consult the account relation. Na? So because the account relation consists the account number, branch name and balance. Okay. There may be possible in a particular branch there is a number of accounts are there. So here for number of accounts, the branch name is the same. Say NIT D. Is it na? Because this account is my account is say NIT D. Your account say NIT Durgapur. Your account, another person account is say NIT Durgapur. So their branch name is duplicated. So I want to eliminate in our result, eliminate the branch name attribute of the relation. So what we write here? Oh no, sorry. Question is different. That is eliminate the branch name attribute from the account relation. So branch name attribute eliminate means which one actually I want to take the information. This account number and balance. So what we write? Please tell me.
Pi account number balance.
So pi account number comma balance inside the bracket relation is the account. Okay, good. So I can tell you this one is the different case. So sorry. So project the desired attribute. What attribute we want to get as an output? That is the account number and balance, because we don't want branch name. From which relation? account relation, because the account information stored in the account relation. Okay, so here any question? Whatever actually I told here, the NIT Durgapur duplication, that is for that actually not a single operation is not possible. So when we use uh, the query by using the multiple operation, at that time we can discuss this one. So this example is clear. Means what is the role of project operation? Now we come next is the how actually union operator is referred by the symbol union, this symbol. Okay, and this is a binary operation. So it takes a two relation as a input, or not a binary. It is a any relation, more than one relation can take as a input. Okay, so it is a binary in that case that R and S are the two relations. Okay, and what is the definition of this? R union S, it can produce as a tuples T. This tuple T is belongs to present in R, or it may be present in S. Okay, just like a union, the nature of union. Okay, so R union S means it provides us a set of tuples. The tuples comes from relation R or from relation S. That is either tuple comes from relation R or relation S. But this operation to be valid if R and S, both the relation, this R relation R and relation S, both the relations are have the same arity, that is the same number of attributes. Okay, if R contain a n number of attributes, then S also contain the n number of attributes. Otherwise, we cannot perform the union operation. Is it clear? And second important point, the attribute domain must be compatible. That is nth column or nth attribute of the relation R deals with a particular type, data type, maybe particular type values, as nth column of S also deals with that particular type. Okay, suppose, for example, suppose the nth column is the customer name. Okay, so customer name is the string, and if the nth column of the S relation is a numeric value, say phone number, or maybe the account number, so there is a compatible these two attribute, though both are actually nth column. You got my understand my point? In R relation, there are number of attributes are there, A1, A2, A3, and so on, say n. So similar S relation, of number of attributes, say A1, A2, say maybe A1, or maybe you can say the B1, B2, B3, say Bn. So this n is the important number of, this is the arity. That is the number of columns or number of attributes in both the relations are same. You got my point now? Both the relation, the n is the number of attributes. Okay. Now another point, this is the first point. Second point is the domain of any attribute. Suppose the domain of this third attribute, a second attribute, say A2, and domain of the second attribute here B2. The domain is the same, contain the same type of value. That is, if it contain a string, here also it contain a string. Otherwise, how we can maintain the parity? It is not the case that A2 is the say customer name, say name, and B2, if B2 is a name, then it's okay. B2 contain name, customer or student, whatever, it's a compatible. But if B2 is a, say B2 is just a balance, okay, name, you cannot perform the name person between two relation R and S. Any confusion or question? So union operation must taken between compatible relation. That is union operation can be possible to perform on the compatible relation. This is the between compatible relation it can perform. So I again just summarize that union operation use this symbol, that is R union S. Here use the two relations as a input. What is the outcomes? Outcomes is the tuples. The output tuples comes from either relation R or relation S. This operation can be valid, that is R union S is possible if both the relation R and S have the same number of attributes. Okay, and also the corresponding attribute, that is the innate attribute of the relation R and innate attribute of the relation S, contain the same type of value. Okay, that is both the relations are compatible. Compatible, when I can say that it is a compatible, if same arity, that is the same number of columns, and corresponding columns are and corresponding columns are same type of value. Okay, this is one point and this is another point. Suppose here two relation R and S. Two relation R and S. You can see here these two relations are compatible or not. These two relations are compatible. Okay, because arity of relation R is the two. How many attributes are there? Two attributes, and here S is also two attributes. Now you can see the domain of the corresponding attributes. What is the domain of attributes here? Character or special character, whatever. Here also the same domain. Similarly, in case of B attributes, n attribute B, here numeric and it is also a numeric. So both the condition, that is the both the relations are actually compatible. So it is possible to perform the union operation. Now if we perform the union operation of R into union S, then what is the result? The tuples, you can see the tuples, all of this actually present here. Now see the alpha to 2. Alpha 2 is already present, so it is not added extra, and beta to 3 is added here. Okay, that is basically duplicate is removed. Is it not? At the intermediate stage, 5 tuples are there. These 3 and these 2, but one of them, that is this one and this one are same. So remove that duplicate. Only one tuple is considered in the final result, because the result is also a relation. Is it clear or any confusion? Anyone please tell me to continue. Means if need to be discussed again, or we can proceed to next.
We can proceed to next.
Okay. So query. Suppose the query is the to find all customers having account or a loan or both. That is, we want to get the list of customers, those customers either having an account in the bank or taking a loan, or maybe both is there. That is, the account is there and as well as the taking a loan from that bank. We want to get the list of such customer. So how we can solve that? Any idea please from your side? Any idea?
Sir, account number union, account union loan.
If we perform the account union loan, then problem is actually there. Customer name is not there. Customer name is there. So, but their problem, what is the problem? We want only, what we want? We want only the customers, not all the details. You got my point? All the customer means customer name basically. We want only the customer name, not the other information. What is the balance or how much amount of loan taken? We are not interested in that. Query is find all customers. That is basically customer names. Which customer names? Those customers having an account or loan or both is there. So not only union is sufficient. So to solve that problem, we can prepare the list of customers. We can prepare the list of customers, those having a accounts. List of customers having accounts. Okay, we want to find, or we want to get, perform some operation that can provide us a list of customers, those have a accounts. Okay, then we also perform another operation, those provides a list of customers. Which customers? List of customers taking what? Taking loan.
Loan.
So now if we perform, that is this is one of the relation, and this is also another relation. If we perform the union of this, then we get the desired list of customers, those having an account or loan or both. Is it not? This is the logic. Means if you think like a programming, so what is the step by step? To get the all list, either account, loan or both, we can prepare the list of customers having an account, list of customers taking a loan, of the list union operation. So how we get the list of customer having an account? What is the, how we write that? We want the account relation. Account relation is needed or it needs?
It's a depositor also.
Good. That is the depositor relation is required. And this one. You can see in the depositor relation, here customer name is there and account is there. Here customer name in the borrower relation here. So from this actually we can prepare what? We can prepare the list of customers having an account. And from that actually we prepare list of customers, those taking a loan. Now both of the list we perform the union operation. So depositor relation and borrower relation need to be consulted. Just a minute. So how we get this list? We can get this list by which operation? Project operation. Because in the depositor, how many columns are there? 2 columns are there. Is it na? Customer name and account number. So customer name and account number, only customer, I want customer name. So what we write here? Customer name, and that comes from which relation? Which relation?
Depositor.
Depositor. Okay. So this actually provide us a, this list of customer having an account. Similarly, which one actually gives us a list of customers, those actually taking a loan? Similar one. You can think like this one. That is a project, customer name. What is the relation name? Borrower. That is, this actually gives us a, this one. That is list of customers having or taking a loan from the bank. And this one actually gives us a what? List of customers, those having a account in the bank. Now we perform in this 2 list what operation? Union operation.
Union.
Okay. Is it clear?
Yes, sir.
Because we want only the information. What information? The list of customers, not the other information. Next one is the set difference. So set difference is just similar to the union operation. That is the, it perform on the both the relation R and S. And what is the outcomes of that? Outcomes is the tuple T. the tuple T belongs to R, but it does not present in the S. Okay, that is the set difference. That is the basic idea of the mathematical set difference is here. The outcomes of the set of tuples, which tuples? The tuples present in the relation R, but not present in relation S. Okay, and to validate this is possible, that is this set difference operation can be performed if the two relations are compatible. That is R and S are same parity, that is the same number of attributes, and the domain of the R and S must be compatible. That is the nth attribute of the R relation and nth attribute of the S relation have contain the same type of data. That is attribute domains are must be compatible. Okay, same condition of the union rules. So again repeat, the set difference R with S is the set of tuples. The result is the set of tuples. Which tuples? Those tuples present in the relation R, but not present in relation S. Not present in relation S. But now we can take the example. Say this is the relation R and this is the relation S. Now I want to perform the relation set difference R minus S. Okay. So what is the outcomes? We can check alpha and 1 here present, no. So it is the one of the tuple as a output. Alpha and beta, this one you can see here it is present. So this is not comes as a output tuples. Okay, that is this is not considered. Next beta 1 is present in relation R but not present in here. So it is considered. Now relation R there is a no tuple. Now consider the beta 3. There is no question to consider that. Okay, we can consider only tuple from the R, those tuple present in R but not present in S. So this is the result of that. Okay, so do you have any question, please? Is there any question or confusion? Yes or no?
No, sir.
Okay. Just a minute. So, okay, thank you. You may leave from the class. I can consider the attendance. Today, I have also from 2 o'clock another PhD interview is there. So okay. Thank you all of you. And those are actually not present, please share with them also.
Thank you, sir.
Okay, well, sure.
Thank you, sir.